For the chapter 4 summary, you have physical layer. The OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. The layer accepts a complete frame from the link and encodes it as a service signals that are transmitted into local media. The encoded bits that comprise a frame are received by either an end devices or an intermediate devices. What are the process of the these are the process that the undergoes from a source node to a destination node. The user is segmented by the transport layer, placed into packets by the network layer, and further encapsulated into frames by the link layer. Second, the physical layer encodes the frames and creates the electrical, optical, or radio wave signals that represents the bits in each frame. For the third, the signals are then sent on the media at one time. And lastly, the destination node physical layer retrieves these individual signals from the media, restores them to their bit representations, and passes the bits up to the data link layer as a complete frame. There are three basic forms of network media. The physical layer produces the representations and groupings of bits for each type of media as copper cable, fiber optic cable, and wireless. For the copper cable, the signals are patterns of electrical pulses. Fiber optic cable, the signals are patterns of lights. Wireless, the signals are patterns of microwave transmissions. Physical layer standards. The protocols and operations of the upper OSI layers are performed in software designed by software engineers and computer scientists. The services and protocols in the TCP or IP suite are defined by the Internet Engineering Task Force. The physical layer consists of electronic circuitry, media, and connectors developed by engineers. Therefore, it is appropriate that the standards governing this hardware are defined by the relevant electrical and communications engineering organizations. Functions. The physical layer standards address three functional areas: physical components and encoding. For the physical components are the electronic hardware devices, media, and other connectors that transmit and carry the signal to represent the bits. Hardware components such as NICs, interface and connectors, cable materials, and cable designs are all specified in standards associated with the physical layer. The various ports and interfaces on a Cisco 1941 router are also examples of physical components with specific connectors and pinouts resulting from standards. While encoding or line encoding is a method of converting a stream of data bits into a predefined code. Codes are groupings of bits used to provide a predictable pattern that can be recognized by both the sender and the receiver. In other words, encoding is the method or pattern used to represent digital. In other words, encoding is the method or pattern used to represent digital information, similar to how Morse code encodes a message using series of dots and dashes. Bandwidth is the capacity of a medium to carry data. Digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. Bandwidth is typically measured in kilobits per second, megabits per second, or gigabits per second. Bandwidth is sometimes thought as the speed that bits travel. However, this is not accurate. For example, in both 10 MBS and 100 MBS Ethernet, the bits are sent at the speed of electricity. Device is the number of bits that are transmitted per second. A combination of factors determines the practical bandwidth of a network, the properties of the physical media, and the technologies chosen for signaling and detecting network signals. Throughput is the measure of the transfer of bits across the media over a given period of time. Due to a number of factors, throughput usually does not match the specified bandwidth in physical layer implementations. Many Many factors influence throughput, including the amount of traffic, the type of traffic, and the latency created by the number of network devices encountered between source and destination. Latency refers to the amount of time, to include delays, for data to travel from one given point to another. In an internetwork or networks with multiple segments, throughput cannot be faster than the slowest link in the path from source to destination. Even if all or most of the segments have high bandwidth, it will only take one segment in the path with low throughput to create a bottleneck to the throughput of the network. Types of physical media. The physical layer produces the representation and groupings of bits as voltage. Radio frequencies are light pulses. Various standards organizations have contributed to the definition of the physical, electrical, and mechanical properties of the media available for different data communications. These specifications guarantee that cables and connectors will function as anticipated with different data link layer implementation. As an example, standards for copper media are defined for the type of copper cabling used, bandwidth of the communication, type of connections used, pin out and color codes of connections to the media, and maximum distance of the media. Characteristics of copper cabling. Networks use copper media because it is inexpensive, easy to install, and has low resistance to electrical current. However, copper media is limited by the distance and signal interface. Data is transmitted on copper cables as electrical pulses. As detector in the network interface of a destination device must receive a signal that can be successfully decoded to match the signal sent. The timing and voltage values of the electrical pulses are also susceptible for interference for two sources. Electromagnetic interference or EMI or radio frequency interface or RFI. Second is the crosstalk. Let's talk about the electromagnetic interface or EMI or radio frequency interface. EMI and RFI signals can distort and corrupt the data signals being carried by copper media. Potential sources of RFI include radio waves and electromagnetic devices such as crosstalk is a disturbance caused by the electronic or magnetic fields of a signal on one wire to the signal in an adjacent wire. In telephone circuits, crosstalk can result in hearing part of another voice conversation with an adjacent circuit. Specifically, when an electrical current flows through a wire, it creates a small circular magnetic field around the wire, which can be picked up by an adjacent wire. There are three main types of copper media used in network. First, unshielded twisted pair or UTP. Second, shielded twisted pair or STP, and the coaxial. These cables are used to interconnect nodes on a LAN and infrastructure devices such as switches, routers, and wireless access points. Each type of connection and the accompanying devices has cabling requirements stipulated by a physical layer standards. Unshielded twisted pair or UTP cabling is the most common networking media. UTP cabling terminated with RJ45 connectors is used for interconnecting network hosts with intermediate network devices, such as switches and routers. In LANs, UTP cable consists of four pairs or four of color-coded wire that have been twisted together and then encased in a flexible plastic sheet that protects from minor physical damage. The twisting of wires helps protect against signal interference from other wires. The shielded twisted pair cable or STP provides better noise protection than UTP cabling. However, compared to UTP cable, STP cable is significantly more expensive and difficult to install. Like UTP cable, STP uses an RJ45 connector. STP cables combine the techniques of shielding to encounter EMI and RFI, and wire twisting to encounter crosstalk to gain the full benefit of the shielding. STP cables are terminated with special shielded STP data connectors. If the cable is improperly grounded, the shield may act as an antenna and pick up unwanted signals. Coaxial cable or coax Coasts are short, gets in, gets in its name from the fact that there are two conductors that share the same axis. Coaxial cable consists of a copper conductor used to transmit the electronic signals, a layer of flexible plastic insulation surrounding a copper conductor. The insulating materials is surrounded in a woven copper braid or metallic foil that acts as the second wire in the circuit and as a shield for the inner conductor. The second layer shield also reduces the amount of outside electromagnetic interface. There are different types of connectors used with coax cable in wireless installations and cable internet installations. UTP cabling standards. UTP cabling conforms to the standards established jointly by the TIA. Specifically, TIA EIA 568 stipulates the commercial cabling standards for LAN installations and is the standard most commonly used in LAN cabling environments. Some of the elements defined are cable types, cable lengths, connectors, cable termination, methods of testing cable.